So we have a cylindrical water tank standing on it, has a radius of 5 meters and a height of 20 meters. If it's being filled at a rate of 3 meters cubed per minute, at what rate is the water level rising when the tank is a quarter full? So we have our water tank that has a height of 20 and a radius of 5, and we want to know how fast that water's rising when it's a quarter full, which would be at 5 meters. So the first thing we need is to figure out what we know and what we don't. Well, we know that the radius is 5, and we know the height is 20, and we know that the rate the volume is changing at. So in our calculus notation, we might denote that dV dt equals 3. What that tells us is we're looking for the rate the height is changing. So we want a relationship between the height and the volume. So for a cylinder, that relationship is pi r squared times h. Now, one of the nice things is whether I'm at 0 meters, 5 meters, 10 meters, 20 meters, the radius is always the same. So as far as this problem is concerned, the radius is a constant. It's only the height that's changing. So if I want to at this point, I can plug 5 in. It would be different if I had a conical shape. I would have to find a relationship between h and r and get it in terms of one variable. But we could rewrite this as 25 pi h. So we actually just have a linear relationship. Now we can do our implicit differentiation. So we get dV dt equals 25 pi is a constant. It comes along for the ride. Derivative of h with respect to time is dh dt. And so what that tells us, notice dV dt does not depend on h. That means it doesn't matter what the height is. The rate the height is going to go up is always going to be the same. And we're going to plug in what we know, which is the 3. And then we have 25 pi dH dt, and we'll divide to solve for dH dt. So we get dH dt equals 3 over 25 pi, and we do want to remember our units. H was in meters, T was in minutes, so this is meters per minute. And again, regardless of what the height is, it's always increasing at that, because notice that the relationship between the rates did not depend on anything else, just a constant.